This is presented by funded by an NSF grant. So, and part of the MAA, AMATIC, and ASA are all part of this grant. So just a couple of things I want to let you know about the webinar before we start is that the MAA is in fact recording the webinar. And so we will be posting that so you can see it a little bit later. Another couple of things I just want to kind of also mention is that we will be distributing it on the StatPREP website. So if you missed it or you want to see it again, you can watch it again. By participating in this webinar, you are agreeing that your contributions become part of the webinar. So if you don't want that, you can mute yourself. Actually, at the moment, you are muted. If you want to, you can unmute yourself so you can participate a little bit. That is fine too. All right, so good afternoon, everyone. So this webinar is going to be about using little apps to teach descriptive statistics. Part of the StatPREP grant, we've actually created little apps that you can use in your classrooms. And so I want to show you where those are and show you how they work. And I'm going to use one today to kind of show you how I teach it in my class. My name is Catherine Kozak. I'm at Coconut Community College in Flagstaff, Arizona. I'm part of the StatPREP leadership team, and I'm also the president-elect of AMATIC. So welcome everyone from all those organizations. Danny Kaplan is also part of our leadership team. So he is from McAllister College in St. Paul, Minnesota. All right, so we're gonna actually talk about the StatPREP website at the start, because that's what we're gonna go into. We're gonna look at the structure of the webinar, of the website, where to find the little apps, and also where to find the tutorials and class lessons we have. So the StatPREP webinar website is just statprep.org. So we're gonna go into that right now. And so this is what our webinar looks like, our website looks like. We have some home that gives you some information about us. We have the different webinars we will be, different hubs we will be hosting here shortly with some, and what the workshops will look like. So we've actually had workshops in Los Angeles and Minneapolis. Those were did the last ones this last summer. And then we just met in Seattle and Hartford, Connecticut this June also. We'll meet again in next summer. And then we have more planned throughout the next few years. This summer, we will also be meeting in Fort Worth, Texas, and in the DC area. So hopefully if you haven't attended one, you'll be able to attend one, and hopefully if you did attend one, you found the information useful, and that you'll be coming back the second time if you're in the first workshops. Again, we do have our webinars posted on here, so you can see all our previous webinars we've done in the past. And then we have our resources. So that's where I want to go, is to our resources. Here we have little apps. They're just things that you can show in your classes. We have a little app on the 2-sample t-test. We have a little app on regression and smoothers, proportions and center and spread, which is the one we're gonna be looking at today. And these are just, and we'll show you how they kind of work, but these are just ones that you can use. These are some old ones that you can also look at and use in your classes if you want to. We also have tutorials. So we have tutorials on statistical basics with R, random-based inference, data wrangling, and modeling. So these are different tutorials you can use that can help you learn the statistics and how to use R, but also if you want to use them in your classes to teach your students how to use R. And then we also have class lessons. Those class lessons, we have a first day lesson that I actually use this semester. We have some other ones that you can use. My favorite one is the experiment where they have the students throwing paper airplanes. Another favorite one is using what's normal and what happens with that and what normal means. And then a couple other ones we have. We're going to be dealing with a little app. The little app is the one that's called Center and Spread. So if you are on the StatPREP website and you want to go to that, you can go there and play along with me. Or if you want to just watch, you can also just watch. So we're going to go into that. It takes a little bit of time to load. All right, so as soon as it's up, this is what our little apps look like. They usually have information that's a graphical display of information. They have a response variable here that's displaying the data, whatever you picked. Right now we picked age. You also have explanatory variables. We'll look at those. And you can change your sample size. And there's some other things we can do. So I would actually use this in my classes to introduce the concept of center and spread. And I'm going to pick a different variable besides age, because that's not all that interesting. This data, by the way, is from the national survey that was done of students. So we have that information. I'm going to actually pick and work with BMI. So you can see we have all these different variables that are looking at this. National Health put out all of this information on people and collected information, and we have that data. And in this list is BMI. So there's the BMI. And you can see here's a dot plot of the BMI information. You have what the BMIs are doing for different people. So how many people are down here around 20, how many people are up here around 40, and of course 60 is incredibly overweight. So we have one person up there. So that's what each one of these dots represent. If you think 200 is too many to look at for your students, you can actually change the sample size to something a little bit more usable. So let's go to 10 just for the fun of it at the moment. So what I would do with my students is I'd say, okay, this dot right here represents a person who has a BMI of about, looks like about 38. So that's one person right there. And this is one person whose BMI is around 17. So I would actually work with that and show my students how these work. You can also take another sample. So down here at the bottom is a button that says new sample. So I can click on that new sample, and I see I get different points. So that's the joy of this, is you can actually show your students that different samples can be taken. These are all random samples taken from that national survey. And this dot here, therefore, is one person whose BMI is around 25. If you want another new sample, you can do that too. And you can see that it shows it's different. So you can talk about how the difference in the samples are happening and what goes with that. 10 is not a very large sample, so we go to a little bit bigger sample. So let's go to maybe 50. And then you can see kind of how that's spread out. And you can kind of estimate right now where the center is. It looks like the center is about here. And it looks like it's got a little bit of a spread. So we can talk about those concepts of what a center is and what a spread is. If you would like to, you can ask them to show the mean. So we can actually click on this and find out what that mean is. So this is the mean for this sample. And if you want to take a new sample, you can do that, and then you can see how the mean changes. So this is one thing I like to show my students, is how the mean actually can change based on taking different samples, because the mean is dependent on what sample you take and so forth. If you want to then go into what the standard deviation is, we can actually show that standard deviation. So this is using the idea of 1 standard deviation, 2 standard deviations, 3 standard deviations above and below the mean. And so you can say to your students, hey, look, most of our data is within 2 standard deviations of the mean. There are some people out here. There doesn't seem to be anybody down here. So you can kind of show that. If we want to take a bigger sample, let's go back to our 500 sample. You can now see how the standard deviation might change a little bit with the different samples. And now how you have some outliers out here that are beyond 3 standard deviations. So you can kind of start introducing those concepts of what those are. I can share the source of the data, but I have to admit I can't remember exactly what it is, so I will make sure I find out what the source of that data is and where it's from, and give you that information. Because I can't remember, I know where it's from, but I can't remember exactly where that data comes from. So let me find that out for everybody. And I will get that information for you. All right. Sorry, I'm just trying to look something up. Okay, so let's go back to where we can go with this data. And I get that information to you. You can also, and this is kind of an introduction to things, you can actually get the idea of doing a median or actually show a confidence interval. So you can actually show the median and a 95% coverage interval. So you can see the median and the mean are pretty close in this sample because the median is this blue line right here, and the mean is a red line. You can also do a confidence interval. So you can kind of introduce that concept of a confidence interval to your students right today. I can say, hey, this is what the confidence interval looks like. This is where the mean is roughly. Now, in reality, in statistics, we don't really spend a lot of time on just a single variable. We spend a lot of time in our classes doing that, but we don't spend as much time as we'd like to do that. So we want to find out kind of where that information comes from and what we can look with it. And so what we want to do is we actually like two variables. So we might actually have an explanatory variable here. And let's look at the explanatory variable. And let's pick one of our many explanatory variables. So as an example, we could look at what is the BMI doing with maybe, let's look at physical active. So you can see here, and I'm going to go ahead and turn off the confidence interval at the moment, but you can look at this and see, hey, people who are not physical active, they have a BMI about here, which looks to be about 30, and people who are physical active have a BMI that's a bit lower. So we can actually start looking at how that interacts and what that looks like and goes with that. So that kind of gives us some information of kind of where that all fits together. All right, so it's kind of a good way to kind of introduce the concept of the difference between things. You can see those the standard deviations are roughly they're a little bit smaller for this sample than for the yes people than it is for the no, but you can kind of still see what's happening with that. And again, it might help to take another sample and see if that changes. And so I like to do where I show lots of different size different samples and keep doing that to show kind of that things do change with each sample. So it looks like at the moment though that this mean does seem higher than this mean. If you want to, you can show the confidence interval between these and kind of talk about how much is it really a big difference between them. So that's kind of a nice thing to kind of introduce your students to the concepts of what these are and what they are working with. So, sorry, I was still trying to find the answer to that question as to where the data came from, and unfortunately, I don't have the exact source, so I'm still looking for that source. If I don't get it, I will put it on the, when we post the webinar, I'll make sure that it's posted with the webinar so you know where the source of the data is. But I believe it is the National Health Survey that's done every year. If you want to also, by the way, you could change your confidence level. So we can go to a 99% confidence level and see what that changes. So you can do that information also and show the median and that confidence. It's called a coverage interval. So you can do that if you want to. And then then what I would do with my students is say, okay, we're kind of done with BMI. What other information would you be interested in? What other thing would you like to look at in terms of this study? So do you want to look at maybe poverty and see with poverty, are things more spread out than others? I'm going to turn off the confidence interval. But looking here at the means, again, I like to use this to kind of teach the idea of the means. And I can see, hey, people who are physical active, there does seem to be a difference between those who are physical active and how much poverty they have. This is their poverty level. The lower the number, the more poverty they have. The higher the number, a little bit less poverty. So you can kind of see where that fills in. You could pick other things. You could pick other home ownership. And this one actually is nice because it has 3 different things. We have ownership, renting, and if you're some other to where you don't have a home or you're living with somebody else, that would be with the other category. And so we have this information from these different places. So again, you can really see, hey, this means for if you own a home, you're most likely to not be in poverty than if you don't own a home. But there's other response variables you can pick on and work with. And so that's what I do. There is the difference between the different colors is this is actually the interval for, this is the mean for this group here, and it's just red, so just say this is the mean for this group. This group is colored green just to show that they're a little different, just to make them different. And this one has the red here, the green here because their color we picked there was green for them. And then the other is blue, and there's not very many of them, so this data probably isn't very accurate as to what that would be. So it's just a different colors just to keep the things kind of separated and what's going on. The black intervals, so the red line here is your means. The black interval is your standard deviation. So this kind of shows you, here's your center, you're 1 standard deviation away, 1 standard deviation below, 2 standard deviations below, and kind of shows you the spread that you would be. So that's kind of what I use with those. And again, I would at this point open up to my students and say, what would you be interested in? Are you interested in cholesterol? And maybe looking at cholesterol and physical active. And you can see that people who are not physical active have a slightly higher mean than people who are. The spreads look to be about the same because this spread is the spread for standard deviation is this black line here. And this black line here is the spread for standard deviation for the yes group. They look about the same, and so forth. So you can kind of talk about those. And yes, they're not actually calculating any of these, but they are in fact, doing a. They're just seeing kind of what there is. They're getting more intuitive idea. So I was asked about the confidence intervals. I was looking at these, and I wish Danny was here today because he could explain a little more about these. These don't look to be what I thought they would be. So I'm not sure. This is supposed to be a confidence interval for the mean, and the mean difference is actually probably what these are, but I don't understand what these are doing. So I have to, unfortunately, Danny's not here today for me to explain those. So I probably wouldn't show those to my students with this kind of concept as what they are. I would probably just spend time with my students with the mean and standard deviation to give them an intuitive idea of what the center is. Because you can see this does look like the center of the red data. And this does look like the center of the green data. And so giving them that idea of what that looks like. And so that's what I kind of would do is go through that, pick different things. Now, if you do want your students to be actually able to calculate these things, we do have the technology for doing that. So again, first I'd like to kind of talk about where does it fit in. I've kind of been talking about that all along, is that I would actually kind of not spend time having my students calculate standard deviation and mean. I'd rather have them have an intuitive idea of what those are. So that's kind of where I would go, is where they would fit in, is kind of replacing my discussion on having how to calculate these with more of an intuitive idea behind them. And then if you do want to teach your students how to do that in R, we do have a classroom lesson or a tutorial for that. So I'm going to open that one up. And so this is what a lot of our tutorials or lessons look like, is they kind of give you on this side. This one is descriptive statistics. And it gives you on the side kind of different pages we're going to go to. It'll give you a little bit of information about what we're starting with and what we're going to be dealing with. And kind of how to do these calculations, because a lot of our classes, we do have to calculate them. I don't make my students calculate anything by hand. I make them do everything on a computer. I used to use graphing calculators. I don't use those anymore. I find that they're very limited in what they can do, and this is much better. So what I want to go on is, if we go to organizing statistics, we can actually talk about how we do this. We are going to be using, basically this is R. It doesn't look like R. It allows you to actually do the code of R. This data is the Galton data. This was actually collected by Fisher back in the early 1900s, that he was collecting information on on people, families' weight, their height, their ages, and so forth. And if you look in the chat, you can go to this one also and go into the signing this app and see how it works. So we're going to go ahead and actually do this. This is actually the command in R to create this. You have to have Mosaic and ggplot installed on your R. But if you're using RStudio, they're not hard to install. We just started using RStudio for our students this semester. And I have all of the packages that I need already in the computer, in the package for my students. But DF means data function. So I like to tell my students that this is kind of the function. This is not an algebra course, but this is kind of like a function. And then the parentheses are the argument for that function. So we're going to use df underscore stats because we want to do a data function creating the stats. And then the parenthesis says, okay, now do it on this. We use the tilde. That tilde is a way to tell R, this is the variable I want to work with. It's not really what that means. It means a lot of different things, but one of the main things that kind of can be thought of as meaning is, this is the variable I want you to work with and where I want you to go. We can also do other things with it, and you'll see that when we get a little bit farther as to what that tilde can also do. And then we need to tell it where the data set is. We're using the data set Galton, and that is also one that you can load into the R automatically. And then we want to have it find us the mean. And then if we just come over here, we can have it run that code. And you'll see it comes out. It only has a one row here because it's just letting you know that it calculated this, and it's finding the mean height of these people. So the way I actually have created R, my college actually has an RStudio license, which is free as long as you can prove to RStudio that you're using, or that you can prove to RStudio that it's in your syllabus that you're actually going to be using, required in your classes. It is free. My students, my IT department then installed that RStudio onto a server here on our campus. And our students log in with the login they use for campus computers. So they only have one login they have to know. And then my students I've been able to tell my IT people what packages I want them to have installed. And then we are actually loaded, and then we just install them whenever we need to use them in our classes. And so my students were actually able to do that. My classroom, we have computers in the classroom. Some of my students bring in laptops if they have them. You can actually do this on your phone. RStudio can be run on a phone, though I wouldn't want to do it on my phone, but it's amazing what some of these younger students like to look on their phone. So you can use a phone, you can use a tablet, you can use a computer, and it doesn't matter what kind of computer. And that's one reason we went to RStudio and log in for RStudio as opposed to using just an R download, is it will work on Chrome because they just log into an RStudio through their browser. So they just go to a website that's their RStudio login, and it brings RStudio straight to them. So our students who have Chromebooks actually can use this. And that was one of our problems we had. All right, so back to this of what we're gonna do. So I now will be teaching my students in class, probably using this exact webinar, this exact lesson here to have my students learn how to go ahead and do things with their computers. So we calculate the mean height, but if you want to, you can change this to anything else. If you want to, you can make this into median. And then it will calculate the median for you. And so here it is. Whoops. I then have to hit run code. And now it gives us the median. And in fact, if you want to, you can have it do the mean, the median, and if you want to, you can even do the standard deviation. And it will actually give you all of those things, the mean height, the median height, and the standard deviation of your height. So you can actually get those calculations for you. I grant you, I'm not making my students calculate these by hand, but I haven't done that for years. So, and they don't seem to have a problem with understanding what these things are by not actually having them calculate them by hand. I do have my students in class doing these on their own so they can see how it works. We can also, and this is the nice thing about the tilde notation, is if I want to do height, but I want to base it on height in terms of, let's say, looking at different genders or different sexes. So I can actually, and if you want to, we can actually look at this data. So I'm going to go ahead and type in Galton. R is very case sensitive. So you notice the first time I typed it, I spoke in a little g, and now I changed it to a big G. So I tell my students that all the time, be very careful. And you can kind of look at this data. So what this is this is the family number, their father's, this is their father's height, I believe, mother's height, the sex of the person, hopefully. And then, oh wait, I think these are the mother and father. Yeah, I think these are their heights. And then this is the height of the person, the kid. So this is the gender of the kid, and this is the height of the kid, and then this is the number of kids that are in that family. So this first family has 4 people in the family, the 4 kids in the family, and this first few people are all the same family. So this is all the same family, and this is the different heights of, this is a kid who's female, this is a kid who's also female, there must be twins. This is another female kid, maybe there's triplets, and then here's a male child. So you can kind of see how that all kind of fits together, and then you can see this family here. So if you want to look at the data, we can look at this and see what's happening. But let's say I want to see, is there a difference between means for different genders? So we can actually run the code. Again, we're going to use df stats. It's really nice because the df stats pretty much does everything. And then the height is going to come first, and the tilde says, take the height and separate it by the sex. So the word that comes after the tilde is what you want to separate it based on. Sex is a qualitative variable, and you can see it's up here as a qualitative variable. Height is a quantitative variable. So you do need to start with a quantitative. You're going to do stats, and then a qualitative variable here. And again, data equals Galton tells R where the data set is. And then this time I'm going to do a confidence interval for the mean. So again, I'm going to run it. And you can see now we had the female data here, and their lower limit of their confidence interval and their upper limit. And then we had the male data here, lower limit and upper limit. Okay. So one thing I want to point out is the way these work with the tilde is if you're only going to have one variable like we did up here. Let's start this one over again. The one variable up here where we didn't separate it based on another variable, the tilde has to come first. And if we have 2, then the tilde can go in between. And then this is nice because it actually has the students kind of playing around a little bit with it, playing some things. The help command is a wonderful thing in R because it actually gives people a chance to tell you kind of what's going on in that data set and some information about it. So this variable of kids' feet, the data was collected by a statistician in her 4th grade classroom in some place. So you can find out information about the data set. They usually have little vignettes about each data set here. And so I would just keep playing with this and let my students see kind of what they can do. And then this one actually allows your students to kind of play around a little bit more with it, to where they're actually having to put in what information they want. So we're going to use the df stats to construct a data table, which will break down the mean width for the 4 groups. Girls whose bigger feet foot is the right foot, and boys whose bigger foot is the right foot. Girls whose bigger foot is the left, and boys whose bigger foot is the right. Left also. So we might do, let's say we're going to do width, and we might want to do bigger foot, and then we might want to do with maybe we'll do sex, and then we see if that works. And so now we can see the sex is boy or girl, and what their left foot is. If their left foot is the bigger foot, what is its mean width? And if their bigger foot is the right foot, what is their mean width, and so forth. So these are just kind of things that they can play around with and see how things work and see what happens. And then this is the kind of, because one of the frustrations my students have is that they get things wrong, and then they don't know what's wrong. So this exercise here kind of lets you see what's wrong. If we run this code exactly as it is, it'll say it can't find this. So you can see, hey, I might have missed something here. Remember, it's not just D, it's data functions. So it's DF. And then stats. So now let's see what happens when we fix that mistake. Now it says it can't find kids' feet. So we then see, oh, well, kids' feet is supposed to be capital. So we're going to go ahead and capitalize that kid's feet. And then, oh, and feet was capitalized also. So you got to be very careful about how things are capitalized. And then it says SEXX is not found. So we know how I need to get rid of one of those X's because there's too many. And then if we run it again, it doesn't know what mean is because we obviously didn't spell mean correctly. So this is a nice one because it gives the students a chance to kind of play around and see kind of what can go wrong. And then there's more topics in these, and that you can go through this kind of similar things that we just went through. So now what I'd like to do, and like I said, I'm not going to go through the whole thing, but it just gives you a chance to kind of play around with all those and see how things work. So I'd kind of like to go back to the discussion and talk about how do I actually assess this data. So one thing I do is I do teach my students the R. So I actually do make them learn R in my classes. And they've been able to learn it just fine. At first, it's not great. I do give them all the commands. So it's not like they have to remember commands. But I do give them all the commands so they can work through it. So in their homework problems, I do make them use the R programs. And then the way I would test it is I would make the computers available. If I have computers available, which I do in my classes have computers available. So if you have computers available and you can lock down the browser to only be on a certain page, I know my software at my computer, my IT department on our computer has actually done that to where you can actually lock down to a certain browser that they can only use. Then I'd be fine giving them an in-class test using this information. If you don't have computers available, what you could do, and what I actually do for my take-home test that I give at the end of the semester, is I actually give them the printout from R, or I give them the printout from the little app and say, tell me what you can about this. What information could you give me from this? So it's more of a conceptual question and not a can you produce it kind of questions. Which really the computation is not as important to me as it is the conceptual understanding of it. So that's the other thing I can do. The thing I actually do in my classes is I'm allowed to give take-home tests if I want to, because I have the freedom to do that. And so I actually give a take-home test. And it's not the normal take-home test that you're used to. It is a take-home test that is a little bit more work. So you can see the link is here, but I'm going to go to that link and show you kind of what my take-home test looks like. And it's not where you fill things in. I mean, they have to do their work on their own paper. And I ask my students, you know, here's a data set. Find me all these different things. Label these different things. Find me I actually have a pie chart in here, but I'm not teaching pie charts this semester. So I have to change that to a bar chart. And then have them write me a summary of that. And I have that where this is all just qualitative data to where I'm having them do a bar chart of it and telling me kind of what story does the chart give them. And then I do grade them based on how well their chart was created. And then I then have them hand in all this information. I'm big in them understanding the definitions of what a population and sample are, so I make them go and write that information for me to see, can they actually take a situation and write it. And then I then go into a qualitative data. So I have a problem that's on a qualitative, sorry, not qualitative, quantitative variable. I do a quantitative variable, and this one is actually temperature data for males and females. And then I have them look at kind of comparing them. Tell me what is the similarity and differences between them. Give me all the means, medians, modes, and all the descriptive statistics you can on them. Draw me some histograms of them. I'm probably changing that for this semester because I don't really do histograms as much as I used to, but I'll probably do a little different things here. Draw me a box and whisker plot, and then give me some information, summarize what you found between these two data sets. I then have them do a stem and leaf plot, and again, the same idea of tell me kind of what this data is, what's going on. And then I do a time series plot, again, just to kind of, again, have them tell me any stories it gives. Another scatter plot that gives the idea of into what kind of correlation and causation kind of things. And then I'm going to finish the test. Then I have the last question is where I'm having them actually take a sample from some data I gave them and then find mean and median mode and do the same thing and kind of talk about what those samples look like. So a couple questions I wanted to make sure you knew about my students. I am at a community college. This is an introductory statistics course. They have had college level math is about all they've had. Some of them have had pre-calculus, some of them have had calculus or college algebra. But this is just an introductory statistics course. So my students are about probably the level of your students. This is the first time some of them have even played with a computer much. They are fine doing it. They learn it all, they go through it. Then to get their own data into RStudio, there is a way in RStudio, and I can go ahead and bring up my RStudio server. So I'll show you what my RStudio server looks like. So again, this is for just Coconino. So this is the one that will get us into this. This is our credentials for my school. And then I get into RStudio. And in RStudio, I was playing around the other day. It actually saves what you were doing. So that's kind of nice. It doesn't make that all go away. So this is actually a density plot that I was able to create in RStudio. I have the data that my students can read in. I haven't learned how to create packages yet. And so I'm working on that this semester to create packages. But right now, I just have a GitHub account that my students can get access to. I get them the URL for that, and they can bring their data into it. And then all the data is in there. But they also can upload data. So in here, if you click on this window here, so this is the RStudio console. I guess I should go back to that real fast. This is actually the console of where you type most of the things you're going to do in. This is actually the data set that we could work with. This is the environment. So these are actually all the different data sets that I have actually read into mine that my students will be reading into theirs. And if I click on one, right now I'm in grades, but if I click on, let's say I click on annual, that happens to be one of my data sets. Here's my data. If I click on birth control, here's a great one because it gives the location, the type, the method, the year, the data type, and the percentile that uses that. So in the country of Belize, 33.5% use abstinence. So this is just different data you can look at that I've created in here. It's another one where it gives you the type, whether they are normal brain or have schizophrenia, and then what their brain volume is. These are all things that are from my course that I teach in my book. And I was able to put this information in. And then you can actually upload. You can just go and choose your file. Most of them should be CSV files. That's the easiest ones to bring in. I don't have one on, well, maybe I do have one that I can bring in. So let's see if I can find one on my data set. Wait, sorry, I gotta find them on my computer. So let me go into my data sets, and let's say I've got one here that is this is a CSV file. This is Australian. I don't know what this data is until I open it. It's some data from Australian, and then I can say, okay, I want to open that, and then it'll bring that data set in for me, and then I can click on it, and I can actually import it. Oops. And then I can tell it to import it, and then it comes right in, and there is my data set. So this is actually the assets that the Australian government had over a certain time period. So that's what this data set is. And then we can do different things with it. So I can import them by just doing that upload and then import it, and then it puts it right up here into my information. And I can do different things with the RStudio. So I give my students this ability to get in here, and they do with it. I did not set up my RStudio. I actually told my IT department I wanted to get RStudio, and they set up the server for me. So I just let them know I wanted it. They then came back and said, no, it costs $10,000. And I went back to them saying, no, it's free. As long as we're an educational unit and I have it on my syllabus that is required. I sent them my syllabus, and they sent that off to RStudio. And then RStudio was able to give them information on how to put it up. They said they thought it was going to be really long, and I got them back in June. I brought this up, the idea of putting RStudio in. Actually, it was the end of June, but I said I really want to get RStudio. And by July, middle of July, they had it set up. So it wasn't hard for my IT department to get one set up. They were able to do it without any problems. And one of the guys is in charge of kind of looking it over and watching it, and he says it's not that hard to work and maintain. So my IT department was pretty well willing to do this, but they didn't find it a difficult thing to put together. So that's my RStudio server. So now let's go back to, and you're going to notice here in the test, I actually, in here, when I go back to my test, I actually give them the thing that will bring this data set in. So this is the marijuana. So I actually give them the name of it. And then I tell them I'm going to read, I actually have to change this because this is not correct, but I would read in a CSV file. Then I would give them the login, the web address for my GitHub account, and then the name of the file. So I have to change this. This is actually not the data set I would use this semester anyhow, because I used it last spring, but this is kind of what I would go through and use. The data actually came from, so the data for my textbook came from my textbook. I actually have the access to that data set because I actually wrote my textbook. I actually was able to, I had a sabbatical and I wrote a textbook because I wasn't really happy with the textbooks that existed out there. And so I have the data sets available to me that way. If you get a publisher textbook, a lot of time they have the data sets available for you somewhere else. I got the data for those from just kind of searching around. I was in Australia for my sabbatical, and I went up and looked up data there. And then for the data for my test, I actually got this idea of a test from a friend of mine. And once I got the idea of his and what he was using for the data, I was able to start looking for that kind of data. And believe it or not, when you Google, like if you Google marijuana, the data comes up. You can find information. The World Health Organization has tons of data sets you can go and get into. That's where a lot of these came from. But a lot of times I just Google, hey, I'd like to do something on this, and I see kind of what data I can find from it. So that's usually where I get this information, is searching that way. I was also asked the question of which is more friendly, R or RStudio. And I have to tell you, after using both, RStudio is way more user-friendly putting data into R was very difficult. Putting it into RStudio is much easier. The other thing though is I started with R. So if you're new to doing this and actually putting R into your classes, I actually started with R. I made up a flyer I give out to my students, or a PDF file that I give out to my students that kind of talks about how to do things in R. And then I was able to kind of learn how to do things with R. RStudio would do all the things that R did. It's just a little bit more user-friendly for the students. But I was using R up until this semester, and I found it okay. And it was the way I kind of learned how to put this kind of stuff into my classes. I used to use, like I said, I used to use graphing calculators. And about 4 years ago, I said, no, I kind of want to use computer program, and R seemed like the best idea because it's free. So I started using R, and now this year I started using RStudio. And I'm really glad I went to the RStudio. I think it's going to be much easier on my students. There's a couple of things I don't like about it, but mostly it's okay. I should say, wait, sorry, let me go back. Go back for just a second. I want to actually go back. I can't out of here. For just a second, I wanted to go back. If you go to the StatPREP website, there is actually under plus, there is suggestions for data sets. So we also have some data sets here that you can use and find. There are data sets built into RStudio also that will work on it. So there are different things that you can use for data sets, but I've actually found most of my data sets by just Googling something I'm interested in. Like I said, the World Health Organization, Google has tons of data sets for free that you can use, that you can access for free. So I just usually go into those two places. CDC has lots of great data. I haven't actually had my students using RStudio but getting it downloaded onto their computers. So that question was asked is, if it's run on their own computers, do they need to learn R HTML file? I believe if they just download, actually I did download RStudio onto my computer just by itself, and I did not need to learn R. So I just needed to load in the different ones I wanted to have, and it worked. So I just made sure I had installed certain packages I wanted to have. So the last thing I just wanted to kind of mention, kind of going back to where we were, is you've been asking lots and lots of questions, and I'm hoping I've answered most of them. You're more than welcome to ask more questions. So if you have any more questions and you would like to speak, we can certainly do that. If you want to actually come on and talk instead of typing, that'd be fine. I can also, if you go to the StatPREP website, it has the information of all of our contact information. I am more than welcome to answer questions through email. I gladly do that. I will share anything with you. You have my tests. You're able to find that. I do change it every semester, or try to every semester. But I also will share anything I've created. So please let me know if there's anything else you need. So are there any other questions that I can answer? Well, I'm not hearing any questions. I want to thank you for taking your time to be here. I hope you got some ideas of how you would use this in your classes.
Hold on, Kate.
Yes, go ahead.
People who are trying to speak, so I'm muting them now, okay?
Okay.
Go ahead, Andre.
Hey, can you hear me?
Yep.
I can hear you, yes.
Oh, well, first, thank you so much for your presentation.
You're welcome.
I wanted to ask about, given the fact that this course requires a lot more in terms of learning to program, is it equivalent to the traditional intro stats class, or do you label it differently in the catalog or in the schedule, the course schedule, so students recognize that this does kind of have a computer science component to it?
I actually don't label anything different. It transfers to our universities directly as a stats class that they have at their universities. It's just an intro to stats course. I just require them to do some of this. I do give them most of the stuff that they have to do so that they don't have to kind of really learn too much programming.
Mm-hmm.
To give you an example, I had a student who was in my class last fall in stats, and I taught them all. He was a C student. He wasn't my best student, but he was a C student. I had him again in spring in a business calculus class. And in the business calculus class, we were teaching about finding the normal distribution and finding probabilities with that. And in that class, I had to use the graphing calculator. And he said to my students, "Oh, I'll show you how to do it in R. It's so much easier."
Yep. Yep. That makes sense.
Even students, they at first they get really nervous about it, but most of the students by the end of the semester were fine with it, and they were having a good time with the R. So even though it has that computer science to it, they don't really see it as being a computer science class. And the way our classes work also is we actually have the math stats class, and we have a psych stats class, and we have a business stats class. And our math stats and our business stats are actually offered at the same time in the same room with the same teacher, so that we can have a little bit more flexibility for offering classes. So the business students actually are getting the same thing the math students are getting. Our psych stats has just decided to start using R also.
Got you. Thank you.
You're welcome.
All right, you have one more from Udani. 1 second.
Go ahead, Udani.
Hi, Kate. Question is about the Little Labs. I just want to know if you have any like set worksheets to go with Little Labs, or is it just something you just pull up in class and sort of talk about it, or do you have any like written out tutorials or worksheets to sort of like you can give a handout and ask them to look at, Little Labs or?
So it depends on what I'm teaching that certain day.
Okay.
I actually have a worksheet for finding mean, median, mode, and standard deviation, and all that fun stuff that I created myself that actually shows them how to use R. I have to update it because we're now using RStudio, but I'm going to be doing that in the next couple of days. And then I have a worksheet for when I do t-tests later on in the semester and confidence intervals. So I do actually have some worksheets for those. I'm more than welcome to share them if you email me.
Okay.
And then, but some of it, I don't give them worksheets. Like right now, we're starting to do descriptive, we're just starting to do graphical statistics, graphical descriptions of data. And I'm just gonna go through in my class and talk about it. I use a smartboard in my class so I can actually copy what I typed into R into my smartboard notes, and then I post my notes.
Oh, okay. Because I was just thinking if I were to just do an open discussion about like one of those center spread kind of Little Labs, or can I actually give them a tutorial, like a paper, like a printout, and say, okay, go to Little Labs and like look at this?
I don't actually give them something to do. I just have them go to the little apps and then kind of write what they get from it. So I don't actually
like a discussion.
Yeah. So I usually do it as an in-class discussion and have them kind of summarize what they see. And then some of the class lessons, I have them actually write out kind of what they're actually doing. I do one of the class lessons and I have them write kind of their conclusions from the class lesson. So it depends on which one I'm doing. And then I was asked how much time in my class is dedicated to R programming. It's kind of the same amount of time that was dedicated to showing them how to do the calculations by hand. So I don't make them do any calculations by hand pretty much in my class. And so instead of showing them how to calculate the standard deviation using the formula, I usually show them how to calculate the standard deviation using R. So I've just replaced that component of doing calculations by hand with the R component. So it actually doesn't take any more time in my classes than what I was doing before.
Yeah, no, I mean, we do sort of use tech from COC, so we do use tech in class. So I just wanted to see if it is going to be like an open discussion kind of a thing in the class, or can I make it like more, go home and mess with it, twerk a little bit and see if you can figure out, okay. Yeah, you can and probably I can write a worksheet as well.
It depends on your way you teach, your teaching style also. My class, I try to be more open discussion, and see what they kind of come up with, and then some of it is worksheets. It just depends on what my plans are for the day.
Okay. Thank you so much, Kate.
All right. So we're almost out of time. If there's not any more questions, I do want to remind you that there is a survey that is available to kind of talk about how this went. And so it would be great if you could fill that out, because we do need that for our information, for our data stuff. And so please fill that out. And like I said, my information is in the, my information is on the StatPREP website. You're more than welcome to email me, and I will share things with you. Just ask me specifically for what you want. I also want to let you know that we are doing more webinars throughout the semester. So you'll see us, we'll try to do another one. I'm thinking we'll do one in the middle of October sometime, or the end of October. And it'll be kind of on how to teach using hypothesis testing and confidence intervals using the little apps. And then we'll have another one hopefully at the end of the semester, and then we'll be doing more next semester. We haven't planned all those out, but we'll be sending emails out with that information. I want to thank everybody for wonderful questions and for being here. This was wonderful. So thank you, everyone.
All right. Thanks, Kate.
Thank you, everyone.